Here's a simple console application that I built in order to demonstrate how to use linked entities and various other querying techniques against AdventureWorks LT 2012 model. Alright, so the project name is AWLT, and like I said, it's a console application. Here's the main method. So this is the entry point into the application. As you can see, I immediately instantiate a context object using my AWLT entities object. So that's a DB context object that I built the model using. And then I have a number of statements here, most of which are commented out initially. And I'll comment out and recomment those as I want to execute individual blocks of code. So it's console application. I have a console.readline here so that the window doesn't disappear. We can see the results. And I'm just writing out a sample of the results from each of the queries that I'm executing, or some sort of a status message, depending on what's going on. All right, so the first one is a very simple query. It uses this code right here. And this is just about the simplest link expression that you can use. I'm using that context object that I'm passing into the method, and that's a pattern that I use throughout this code. And it grabs customers there. So this is going to return a set of all of the customers within the database. And there's some 847 or something like that in the customers table within the AdventureWorks LT database. All right, so this is the complete link expression. So it's using that customer's property of the context object in order to get access to those customers. Now, as you'll see, as we look at more and more complex queries, then there'll be additional things that you can do here in order to filter, sort, project the results, do all kinds of different things. Linked entities is a very powerful technology. Okay, so at this point, once this statement executes, customers has a reference to all of those customer objects. And again, customers and customer objects are defined within the AWLT entities model, my entity data model behind this code. And then the rest of the code is just user interface code. I'm using a for each to loop through each customer object in customers. And this, in fact, is going to be a customer type. I'm using the var just as a little bit of a shortcut, but you can see that this is actually a type of AWLT customer. And then for each of those customers, I'm just writing out three of the fields, three of the pieces of data that are provided within that customer table within AdventureWorks LT. All right, so I'll go ahead and execute that. And it'll take a few seconds. It'll instantiate that AWLT entities object, execute the link expression against it, and then loop through and display all of this data. And there you can see the company name, first name, and last name for all of the customers within the AdventureWorks LT database. All right, so that's easy enough. You can display data. You can use this obviously in any kind of .NET application. It doesn't have to be a console application, ASP.NET, WPF applications, whatever you want to do. But the nice thing about running this within Visual Studio is that you can take advantage of all of Visual Studio's debugging tools and technologies. So if I come over here and put a breakpoint here as it's looping through each of those customers, I'll run it again. And first thing I'll do is get rid of that window. Not going to use that right now. And so you can explore what these different object types are. So I can expand this. You can see the select statement that it is grabbing. I can look at the results view. That's a little bit less helpful. But I can drill down into these and look at all of the different object types that are being used here. All right, so that's for customers. And this is the customer's object. And actually what I can do is, I'm going to get rid of that and look at the customer object. And you can see that this is a customer object, but it's actually a temporary type. It's a materialization of the customer data. But it's the specific type that's exposing here is AWLT customer. And again, when I created the entity data model against the AdventureWorks LT database, this is one of the entity data objects that was included within the model because I included the customer table. And so this customer type is, in fact, that proper case customer that is provided by my entity data model. Okay, and there you can see that object is actually one of this, essentially a temporary object that was created behind the scenes by Entity Framework. All right, so that's just a very small example of how it's beneficial to run this code within Visual Studio because you can explore the different objects and see what's going on. You can drill down into their properties, take a look at the data, and troubleshoot and find problems. And sometimes I've even found problems with the design of my model by exploring what I'm seeing within these different objects. Okay, so I'm going to stop execution of this. Okay, and one thing about this var keyword here, you'll see me using this a lot with Entity Framework code. This is just a convenience. A little bit of background, just make sure that you're familiar with the var keyword is. This lets the compiler determine the correct type. It actually does that determination at compile time, not at runtime. So it's not like an old VB6 variant type. Okay, so the var is convenient because I don't need to remember, okay, what type is a customer? Okay, that's pretty easy because it's AWLT customer that we saw. But there's other objects within your model that might be more complex, and you might have to spend a lot of time looking up what the individual objects are. So by using the var keyword here, I'm just telling the compiler, figure it out. I don't need to know what it is. I know that this customer object has these properties because that's what's defined in the model. That's all I need to know for writing my code. But if you want to make your code more explicit and readable, you can explicitly declare the customer type variable as that type awlt.customer. And you can, if you're using the customers collection, it can be as the type system.data.objects.objectset or dbset, depending on whether you're using object context or db context. So you feel free to do that. You don't have to use the var. It's just a convenient, it lets the compiler do some of that work for you. Okay, now, so that's the code that executes. Again, this is that very simple link to entities query that I've performed here. Now, whether you run this code in a Visual Studio application like this or in LinkPad, it uses classes that the Entity Framework generates at project build time from your entity data model. Now, the easiest way to see these classes is by coming over here to Solution Explorer, right-clicking on the project, and selecting the View Class Diagram. And that's right here, and View Class Diagram. Okay, so this is a really nice view which includes all the AWLT entities and the context object. So I have address, I have customer, customer addressed, product model, product category, product, and so forth, as well as this context object, and you can see that it derives from DB context. Again, had I built the model using object context would show there. Okay, so again, this includes the context object and all of the tables and views that I included when I created the model, when I reverse engineered the AdventureWorks LT database. Now I can expand each of these objects by clicking on that chevron there. Notice that unfortunately this is a little bit of downside of this designer. These other objects are overlying this, even though it's expanded, but I can move it over here to the side and I can see all of the properties that are available within a particular class. Okay, I'll move back approximately where, and I'll do the same thing with AWL entities. I'm at a fairly low resolution here, so this works a lot better if you have a higher resolution monitor. But anyway, I'll get that out of the way. And there you can see the context object. You can see all the properties. So as you can see, that's all of those collections of objects that are included. And then there's some methods that give you a reference here to this AWLT and also lets you explore the on-model creating event. Okay, and again, the context object derives from DB context. And that's the default within Entity Framework 6. It used to be object context, now it's DB context. Okay, then I close this class details window here, but you can see the types for each of the collection properties here within this window. So you can see the different methods there, as well as those different properties. These are the same properties that are displayed right there. And there you can see the type. So here, because again this is DB context, the collection is of type DB set a generic object here of type address. And there's the customer object. All right, and there you can see the complete code, or the complete object name. If I widen that a little bit and hit the home key, so you can see that it's system.data.entity.dbset of type AWLT customer. All right, if I move off that, you get the shortened name version of that. Okay, and so you can scroll through the list and see all of the fields. This object doesn't happen to have any fields, but if it did, it would display there. And I can do the same thing and display the information for the customer object, which is one of the entity data objects. And here you can see there's a customer method. And I can expand that, see that there's no parameters. And then here are the properties that are exposed by that customer object. And you can see all of the data type for those objects and see whether they're fields and events. Now, just keep in mind that, once again, this is derived from DB_context as the context object. You would see some different information here if this was an object context. Object context, again, is the superset of the features within any framework, but most of the time you can get everything that you need of the infrastructure just by using the DB context. Oh, one other thing to point out here is that customer addresses is a navigation property of the customer class. This property gives you access to the collection of addresses that are in the database for this particular customer. And you can see that it's implemented as a collection interface of type customer addresses. So this, again, is a nice way Entity Framework makes available related data to the customer's object, as long as that related data is included within the entity data model. Okay, so that's some features that you can use in order to explore the model and the classes that are provided by the model. If you want to explore the code that implements these classes, then you can come over here to Solution Explorer. All of the code is included as children of this awlt.edmx file. Once again, if I double-click on the edmx file, that opens up the entity designer, or the data model designer for this particular class. But in Solution Explorer, that's also the container for all of the code that was generated. All right, so if I want to look at the code behind this, the first thing I want to look at is awlt.context.cs. So this is a file that Entity Framework generates at build time. All right, I'll double-click on that, and as you can see, this is the partial class that implements that AWLT entities context object. And here's where you can see this is the code manifestation of the fact that it inherits from DB context. All right, and then it has a constructor, and then this is where it implements all of those properties, those collection properties. As you can see, they're returned as DBset, generic DBset objects. Okay, and then if I come over here to Solution Explorer again, and look under this AWLT TT. By the way, the TT is just the T4 transformation template that Entity Framework uses by default to generate its objects. That's a feature of Visual Studio. You can see the implementation of all of the entity data objects. And so here's the code for customer.cs. And so you can come in here and see that it's a partial class. It's got a constructor. And that basically is to implement some navigation features to related objects and see the code that implements the different properties of this class. So you can see how those properties and methods are actually implemented. Okay, so that's a quick look at the code that is behind these objects, that because I'm running this code within this application within Visual Studio, I'm able to explore, and I can step through the code if I need to debug a problem, and I can explore and debug this code as well. Because maybe I might find that Entity Framework generated some invalid code, and I may not realize it just by looking at the entity data model, but I can see it here within the code itself. Now, one big caution. Tempting as it may be, you should never customize the code files within this .edmx file. In other words, anything that is a child within Solution Explorer of this data model designer file. The problem is that Entity Framework recreates all of these files whenever you change the model and save it. So all of your changes would be lost if you modified these files. There are, though, other, better ways to customize the model. And one big way, kind of a clue right here, if we come back over here to the customer class, is that these are implemented as partial classes. And so you can create your own partial class called customer and add additional features to it. And that's one of, well, several different ways, but it's probably the most powerful way to customize the entity data objects that are generated by Entity Framework that you can use within an application.